Welcome back to another segment on inverses. Last time we used the definition to test and see if two functions were really inverses. This time we're going to learn to find inverses. So remember, we do not test to see if functions are inverses by finding an inverse, but rather by the definition. So they're two separate things. So let's go to our first problem. F of x equals x cubed minus 2. We are to find the inverse function, and notice we are to write it in function notation. We'll have a y for f of x, but the other y is going to be f inverse. So to tell them apart, we really need that notation. We're also going to state the domain and range of both f and f inverse in interval notation. So we'll come back to this slide to see if we've done everything in just a few minutes. Okay, let's copy our function down again, which is f of x equals x cubed minus 2. And first of all, we're going to deal with the domain and the range. Now think with me a minute. Can we use all real numbers, or do we have to rule some out? So I assume I'm using all real numbers until I find a reason. Now remember what our reasons were. If we had an even radical, we couldn't let a negative number, well, we don't have a radical at all, so that's not a problem. We couldn't let 0 occur in the denominator, well, that's not a problem either here, is it? So we can use all reals here, and all reals in function notation goes from minus infinity to infinity, and remember the infinities get parentheses. And of course, no matter what I put in for y, I can find an x to go with it, because I have an odd degree here. Okay, so again we have all reals, which in interval notation is minus infinity to infinity, and that is the domain for f rather than f inverse. Now, do you remember when we were doing ordered pairs a few minutes ago that we flipped our x's and our y's? I think that's what we need to do to get an inverse here too. Just flip the x's and the y's. So the second thing I'm going to do is put in a y in place of my f of x so that it'll be less cumbersome. But I have to remember that this y right here goes with f. And now I'm going to switch my x's and y's. So x equals y cubed minus 2. Now this new y is the y of f inverse, just like this y was the y of f. Also, our domain and range switch at this point. So we're going from minus infinity to infinity. Again, minus infinity to infinity, a little bit trivial switch, but this is the domain for f inverse now, and the range for f inverse. So we've switched our x's and y's, both in the domain and range and in our function here. But usually we see functions solve for y, so that's what we're going to do next. We're going to solve for y. So if I want to get y by itself, I'll add 2 to both sides, and I will have y cubed on one side and x plus 2 on the other side. And then if I take the cube root of both sides, I get y equals the cube root of x plus 2. And that is our inverse, because at this step, when we actually switched x's and y's, we had the inverse. We just didn't have it in good form. And now to indicate that it is the inverse, we're going to write it as f inverse of x equals the cube root of x plus 2. So this step we'll call use inverse notation. Okay, Let's find another problem to do. If we have f of x is 3 divided by x, we're going to find the inverse function f inverse of x, state the domain and range of both f and f inverse in interval notation. Exactly the same steps we followed a few minutes ago. So let's get us a blank slide here and write down f of x equals 3 divided by x. I'll tell you what, let's go back a couple of slides and do this. Let's change this to 3 divided by x. And I know this is a mess, but I'm going to clean it up because we can see our steps here if I use this slide again. And I think that'd be nice to see the steps again. So first of all, we're going to do the domain and range. Well, I think I have a reason to leave off a number here because I don't want that denominator to be 0, so x can't be 0. So let's see, on the number line we'll go from minus infinity up to 0. A parenthesis says we don't include it. A parenthesis on the other side says we start back on the other side of 0 and go to infinity. And it's the union of those two intervals for our domain. Or you might use a comma. It depends on what your homework program requires. And you know what? I don't have any idea at this point what this range is. It's just a little bit hard to tell what the range is. So I've got a plan. I'm going to wait and see if I can find the domain of the inverse, because if I find the domain of the inverse, it will be the range of f. So I'm not going to worry about the range of f at the moment. And I do this only when I have a fraction. Usually I can come up with that range fairly easily. So that's my plan. All right, let's get started. First of all, we'll put a y in for our f of x. Then we'll switch our x's and y's. So x equals 3 divided by y. That is actually the inverse. And the range of our inverse now, let's get that over a little bit. It's not writing very well here. So we're on f inverse now, is going to be minus infinity 0, 0, infinity. And this time we'll use a comma because I'm not sure what your homework program might want you to do. But we still don't have the range. So now we'll solve for y, back over to our problem. We'll solve this for y. Well, let's see, if I get rid of my fraction, and to get rid of fractions, remember I have to be able to do something to both sides of an equation or inequality. So now I have xy equals 3. Divide both sides by x to get a 1y. And my inverse is y equals 3 over x. You know what? I can tell right now what the domain of the inverse is. X can't be 0, can it? So minus infinity to 0, jump over 0, go to infinity. And now I can take that right back up here for the range of f, which is minus infinity to 0, union, 0, infinity. So now use f inverse of x equals 3 over x, and we have it in function notation. We found the domain and the range. You notice anything kind of spooky about this? F of x equals 3 divided by x is its own inverse. That's unusual, isn't it? That's why I picked that problem. I wanted us to look at a problem where that happened. We're going to find the inverse of this function now and put it in inverse notation. Notice they don't tell us we have to get the domain and range, but you know what? If we don't keep up with the domain and range as we work along, it just may rise up to bite us somewhere. And I'll have a problem where it does show up to bite us. So we'll think about that when we get to that problem. So let's get us a blank page to start working on this one. Okay, let's copy our problem over on a new page so that we have room to work. Divided by the quantity x plus 4. And we'll first of all work on the domain and range. It's pretty obvious that x cannot be -4 or we'd have 0 in the denominator. Now since I've not been required to write the domain, I'm just going to do what I need to work the problem and not worry about anything else. And this is one of those where it's hard to see the range at this point. So I'm going to wait a little while and get the domain for f inverse, and then I'll know the range for f here. All right, first thing I'm going to do is put in a y for f of x and get 2x minus 3 divided by x plus 4. Then I'm actually going to get the inverse by putting x in place of y and y in place of x. So 2y minus 3 divided by y plus 4. At that point, the range of f inverse is going to be y cannot equal -4. So if I need that anywhere along the line, I have it. So this is for f inverse. Okay, next we'll solve for y. Let's see, I think I'd like to get rid of fractions. If I multiply both sides of my equals by y plus 4, I should get rid of my fraction. Remember, I can't get rid of fractions unless I have an equals or an inequality, because I have to be able to do things to both sides of the equation or inequality. So on the left side, we have xy plus 4x. And then on the right side, I chose y plus 4 so it would divide out with the y plus 4 in the denominator and leave me 2y minus 3 divided by 1 in the end. Now let's see, if I'm solving for y, I need all the y's on one side. So if I subtract 2y from both sides, I'll get xy minus 2y plus 4x equals, check and make sure I'm not thinking backwards. Sure enough, that adds up to 0, and 0 and minus 3 total -3. So now I want to get rid of my 4x because I want only y's on this side. So now I have xy minus 2y equals -3 minus 4x. Let's make sure this did what I thought. Yep, I thought forwards instead of backwards. And now I would normally divide by the coefficient of y, but I've got 2 of them. I really need 1. Oh yeah, I could factor out a y, couldn't I? So let's pull out a y, and y times x gives me xy, and y times minus 2 gives me minus 2y. And now if I divide both sides by x minus 2, I'll have my 1y that I'm looking for. And I also see that x cannot equal 2. And this is my inverse I'm working on. That means in the range, y could not equal 2 for the range of the original f. So now I have y, which I'm going to call f inverse of x, equals minus 3 minus 4x divided by x minus 2. And I don't have to say comma, x cannot equal 2 here, because it's obvious to anyone that they don't want to put in 2. Because if they put in 2 right here, they'd get 0 in the denominator. So at that point, they'd stop. So it's not necessary for me to write the domain of f inverse right there. And we'll take a break from inverses for a few minutes.